All right. Thank you all for coming to my presentation. All right. For those I haven't met before, my name is Andrew Case. I spend a lot of time working on the Volatility project with a few of my coworkers and friends, and I also spend a lot of time using memory forensics in real investigations, whether it's an incident response situation, traditional forensics, whether we're dealing with malware. And so in this presentation, I'm very excited to show you our latest effort, which is Volatility 3. It's currently in beta, as you will see. It's on GitHub. You can download it and use it after. It's all open source. And as we're going through this, we'll also be looking at what we consider to be the future of memory forensics. So if you use memory forensics in your investigations now, if you're familiar with it, you'll see that we're working more and more towards automation and in general making it easier for new people to get involved and just getting through tasks faster and more efficiently. And if you look back from where Volatility 3 came from, again, if you use Volatility now, if you've used it any time since 2006, if you were a very, very early adopter in the 2006 to 2010-ish time frame, that was Volatility 1. In August 2011, that was the release of Volatility 2. And then ever since then, that is probably what you're familiar with. Again, if you have it inside of like Kali VM, if you grab it from GitHub, the version that's been around since 2011. We support all the different operating systems. We have several hundred plugins to help you with analysis. All of that was our effort to release and maintain a framework that people could use in real investigations and get a lot of useful data out of it. But what not many people know until recently, a couple months ago, we've also been working on Volatility 3 for almost as long. Because with Volatility 2, as I said, it's very good at analyzing one sample. You can find all the artifacts that you're looking for in a very structured way. But at the same time, just the reality of investigations and how we were performing our own IR and the feedback we were getting from the community and our users is they wanted a framework to go beyond what Volatility 2 is doing. So Volatility 3 really started back in December 2011. We've done presentations at some of the forensics conferences since then, so the open source forensics conference, similar ones, where people really want to see bleeding edge stuff really help you. And then, like I said, October 2019, a couple months ago, we released the first public beta. So we'll be going through the updates and some of the features today. And then, like I said, you can definitely use it, and we'll have all the links at the end. And there was a few key things that we wanted to address in Volatility 3 because we got the chance to start over. If you write code, if you're familiar with large software bases, you can only add stuff once to the top. You can only hack stuff in so much before you just say, I want to start from scratch and get a clean look. And if you look back to the early days of Volatility 2006, 2007, 2008, and you compare that to investigations now, there are significant differences. So when we used to do memory forensics way back, some of the first cases I ever did, having a gig of RAM was a lot. Maybe if you had a server, there was 2 gigs of RAM, 4 gigs of RAM. That's ridiculous now, right? Your phone has more RAM than that. If you look at your standard enterprise laptop, desktop that you buy, not even a workstation, just the regular desktop that everyone in the office has, it's 8 gigs of RAM, it's 16 gigs of RAM. If you look at your standard servers, 32 gigs of RAM, 128 gigs of RAM and beyond is what we see all the time in our investigations. And again, this was not something that Volatility 2, how could you envision that 10 years ago? So we had the chance to fix that with the new framework. The other thing that really changed is if you did IR, say 10 years ago, 8 years ago, somewhere in that time frame, there was usually one key server you investigated, right, or one key system. It was the person who got their machine infected through a malicious attachment, or it was the server that the attackers pivoted to and stole the data from. When we do investigations now, and we get the same feedback from everyone else we talk to, it's 10 servers, it's 100 servers. You have companies in the cloud with thousands of servers. So you're not just dealing with one memory sample. You want to be able to get the data from all the memory samples, make sense of it, and you certainly don't want to have to do that in a manual way on your own. And then the other thing is, when you're looking at memory samples and when you're doing the analysis, Volatility, like I said, 5 years ago and beyond, there was maybe 10 plugins. There was maybe 15 plugins. When you do an investigation now, if you're really deep diving a sample, getting all the artifacts possible, you're probably running 20, 30, 40 plugins or more. And again, if you look through all the different operating systems we support, it's something like 250 plugins in total. So it's just a lot that again, when Volatility 2 was initially developed way back in the day, that was not something that was taken into account. And so this is something with Volatility 3, we could really address all of these properly and from the beginning. And then the other thing that changed significantly since Volatility 2 was developed is how fast operating systems vendors are releasing new versions. I think a lot of people are familiar with the Windows 10 pane now, so every 6 months there's a major new version, everything breaks, everything changes. I have some stats here in the screenshot on the Linux release. So about every 60 to 70 days, Linux, the main kernel developers, release a brand new version of the kernel. Data structures change, algorithms change, and Apple's about the same way, right, with all the updates that they release. And so, again, this is not something that you saw 5 years ago, 10 years ago. This is something that changed significantly, and as you can imagine, has a big effect on memory analysis. So we started with Volatility 3, like I said, back in 2011, 2012. And this picture you're seeing is the Git commit logs. So you can definitely see a ramped up effort as we wanted to be able to get this into production, into where people are using it. And now it's a place where instead of just being a test bed for our ideas, it's a real framework that you can use. We'll talk about it at the end. It does not have feature parity with Volatility 2 yet, but it will soon enough. And our goal with this is we want to meet the next decade of memory analysis needs. We did that with Volatility 2. It made it about a decade. There were significant changes, as we just talked about, in the landscape of incident response and machines that you look at. So with the new framework, we want to address those needs and make it as easy as possible for people to use it and get value out of it. So with that said, what's new in Volatility 3? It's literally everything. We started from line 0. We reused no code. Didn't use any APIs. We're rewriting all the plugins. The entire backend was rewritten. Everything was rewritten and redesigned with those goals in mind that I just talked about. So 8 years from now, 10 years from now, Volatility 3 will still be something that we can use in real investigations. What else is new? So it's written in Python 3. If you're familiar with Volatility 2, it's written in Python 2. As we all know, Python 2 is end of life as of a couple weeks ago. Also, with moving to Python 3 and just the way we got to redesign the backend, we have a major performance boost. So again, when you get those memory samples that are 64 gigs, 128 gigs, and beyond, as much hardware in a sense that you can throw at the processing, we'll be able to rip through that data. And then for the programmers in the room, if you ever tried to use Volatility 2 as a library or write like a user interface on top of it, it was not the easiest. We will admit that. Volatility 3, that was one of the main design goals. We know people want to automate it. We know people want to put their own custom interfaces on it. So it was written specifically with that in mind. Another thing in Volatility 3 is you never have to do -- profile again. So, yes. We were not fans of that either. Starting with years ago in Volatility 3, being able to automatically figure out, okay, what version of the OS is this, whether it's Windows, Linux, or Mac, what very specific version. And then in Volatility 2, we called them profiles. They're called symbol tables in Volatility 3. So you still need those definitions, right? You need like the PDB file from Windows, or you need the dwarf information from Linux, but you never have to specify it on the command line. If it's in, you have a directory where it's stored. If it's in that directory, you have the format. We're automatically going to figure that out, and then we can start to do analysis. If we have any malware analysts in the room who try to analyze WoW64 malware, so you're running a 32-bit sample on a 32-bit piece of malware on a 64-bit sample, Volatility 2, it didn't completely fall apart, but there was definitely some annoyances that you had to work around. That is properly fixed in Volatility 3. And then I'll have a screenshot of this later, but being able to automate the evaluation of code in memory instead of you having to disassemble it yourself. And then for developers, as I said, we really wanted to make it much, much easier for other people outside of the core team to get involved. So we have extensive API documentation from day one. It's not something we're going to have to go back and add later. A big feature request was plugins being able to call other plugins. So if you have a plugin that wants to do some analysis on the process list, you just make one function call. You have the process list. You can enumerate it and do what you want. You don't have to set up a bunch of lines of code. Another big request that we had was versioning plugins. So people would write their own plugin or some addition to Volatility 2. It would work, and then 6 months later it would break because we made some internal change that they weren't aware of. So now plugins are versioned. If you make a change to a plugin in the stable code that would break previous callers to that API, you'll be able to detect that because there'll be a version mismatch. And then being able to bring in custom data structures for analysis. So if you have something besides just the core kernel, if there's a driver, if there's a userland library that you want to allow analysis for, that is directly supported. The other thing that we've really focused on is what we call secondary sources of memory. So if you look at Volatility 2 here, you had really just one source of memory, right? You had whatever that virtual memory space was. You could have all the different file formats, so like Lime and crash dumps, but you couldn't pull in anything besides that main memory sample. That is completely different in Volatility 3, and it is natively supported. So if you look at all these arrows and stuff over here, basically what it's saying is when your plugin wants to read data, your plugin will not know the difference unless it very specifically asks, but in most cases you don't care, you just want the data. Whether the data you're looking for is in the main memory sample, whether it's in a page file on disk, whether it's in one of the compressed stores in RAM, your plugin will get at the data the same way. It's very ugly, to put it nicely or briefly, to do that in Volatility 2 and allow the plugins to access the data in that seamless way. That is a standard part of Volatility 3. So you'll see with Volatility 3, especially when we get to the first official release later this year, if you have swap files, definitely the compressed stores that you have in Mac memory and Windows memory, those are automatically incorporated into your analysis. You don't have to do anything else. And then, like I said, another big focus of Volatility 3 was speed. You don't have to look at the stuff at the bottom. The idea is if you see what's in red, that's Volatility 3. If you see what's in blue, that's Recall, which is another memory forensics framework. And then Volatility 2 is in gray. And the takeaway here is you see a lot of blue and grays going off the chart because they take too long, where Volatility 3 is the reds. And so like I said, one of the major goals of Volatility 3 was being able to handle data quicker and then expand that out when you have those huge memory samples, be able to rip through it really as quick as possible, depending on what hardware you're giving us to do the analysis on. And this is a quick example running Volatility 3. So if you don't use a config file, you still have to use -f and tell us where the memory sample is. -r pretty is just saying to print the columns spaced nicely and readable. And then you see the plugins windows.pslist. You get what looks like traditional pslist output. And if you look at the bottom, it finished in 1.1 seconds. And so there's no -- profile. There's no significant delay waiting for data structures to be found and so on. Everything related to Volatility 3, besides the original goals of stability and stuff, speed is a major factor. We want to get through the data as quick as possible. So besides just kind of revamping what was in Volatility 2, making it quicker, making it easier to interact with, what we also wanted to do was support what we consider modern analytics, so memory forensics tasks that people would not have thought of 10 years ago in Volatility 2, and then also what we consider to be now advanced analytics, which we want to try to automate as much as possible. So we'll see some screenshots of this, but being able to automatically figure out what operating system version you're analyzing, what the applications are. As I mentioned, we'll see a screenshot of automatic code evaluation, and then we'll see a little bash loop of looking at multiple samples at once. So one thing that was difficult in Volatility 2, if you had to make it work, was automatically analyzing data structures inside of kernel modules. So if you look at like the network stack of Windows, you have the NDIS filters. This allows malware in the kernel to set hooks and monitor the network stack. They can also manipulate data coming through packets. They can stop packets from being processed and so on. You have the same exact functionality with NetFilter on Linux. It's also abused by rootkits on Linux for the same reasons. And the plugins that we had for this in Volatility 2 were not as thorough as they could have been because Volatility 2 made it very hard to do that analysis in a structured way on modules. In Volatility 3, it's just a standard part. You have the symbol tables for those modules. You know what the data structures look like, and whether the data structure is in the kernel itself or a module, you just write your plugin the same way, and you do your analysis. So now we can deeply analyze these rootkits as part of a standard plugin. I also mentioned automated version analysis, so being able to, in this example, looking at the master keys in memory. So we did a blog post years ago about TrueCrypt master key extraction, but if you look at how that plugin works, obviously it was Volatility 2 in 2014, we had to hard code the offsets. So we had to say for this version of TrueCrypt, this is what a key looked like in memory. For this version, this is what the key looked like. With VeraCrypt, which is the TrueCrypt replacement, they actually provide the debug symbols for every version, And Volatility 3 can just ingest that data. So now instead of having to say, have anything hard-coded, we can just read that data directly out of the PDBs. We now know exactly what that data structure looks like in memory, and no matter what the version is, even if we've never seen it before, as long as the data structures haven't changed as far as the names or the algorithm, if it's just the offsets changing, the framework can handle that all on its own and do the analysis. So it's much more flexible as far as analyzing different versions. The other thing we do, and this is something that helps us a lot in our cases, we had feature requests for from quite a few users as well, is getting the symbols that addresses map to. So the SSDT is the system call table on Windows. If you ran this in Volatility 2, you just got the first 3 columns, the index, the address, and the module. But that doesn't tell you a whole lot. It says this address inside of the kernel is implementing that operation, but it doesn't actually tell you what that symbol is. So with Volatility 3, everywhere possible where we give you output related to a kernel operation, you also get the symbol name. So you can imagine if you build a baseline of this, you have a very specific baseline that you've built. You know exactly what functions should be handling certain operations. And then also if you just want to understand, okay, what is this code doing, whether it's a piece of malware, whether it's like an AV tool that's running on your machine, you know exactly where to look and you get some context for your analysis. And then, like I said, another big goal was automatically evaluating code in memory. Has anyone used vol shell before and then the dis function to disassemble code? Okay, only a few people. So this is something that a lot of people did not want to do in Volatility 2. Basically, you had to hand reverse engineer code inside of Volatility, code that could be throughout memory, follow the jumps around. It was certainly possible, but it was not easy. So what we're looking at on the left here in this first column, this is the API hooks plugin to Volatility telling you that inside of the Internet Explorer process, this particular function, so LDR load DLL, within this DLL is hooked. And all it tells you about it is basically the first 2 hops of the disassembly. It says the first instruction has been overwritten with this jump, so that's the initial hook, and then that jumps out to this region, which then jumps out somewhere else. So at this point, you have to jump into vol shell. You have to follow all these jumps around yourself inside of the little disassembly interface, and it's very slow. You also have to be really good at reverse engineering to come to a definitive answer of, is this hook malicious or is it benign? And if it is malicious, what is it actually doing? And then if you look at a real Windows system, especially like with AV installed, you have tens of thousands of these hooks. And so you literally have to go through each one if you want it to be thorough. No one wants to do that. It takes a lot of time, takes a lot of skill, and it's not repeatable. So if you look over here on the right, instead of this view, this is kind of an updated version of the API hooks plugin that does automated evaluation of code. So what this one is saying is, in that same process, this same function has been hooked, but instead of giving you disassembly, it's telling you the memory regions that the code moves through. And instead of just being these 2 hops, it evaluates all the way through until that hook is done. So what it's saying now is that this hook first starts in this non-file backed region that's paid execute read write. So you're probably thinking, okay, this is shell code, it's probably bad. But then if you keep reading, you see that it's actually moving through the AVG DLLs. And so you see this AVG SNX hook, you see the ASW hook, and if you would keep going down, you just keep seeing more AVG. So this is very common. This is where AV will try to hide itself from the machine, from malware on the system, because it doesn't want its hooks removed. But to figure this out by hand would probably take 10 or 20 minutes, even if you're good at assembly or disassembly. Where with this, we just automatically tell you, hey, there's a hook. It's placed there by AVG. You can move on. Same thing we talk about in the paper where we publish this. You can also just build a whitelist out of it, right? And say, if these hooks come from AVG, don't show them to me in the first place, and now they're just filtered out automatically for you. So again, whether it's code in kernel memory, whether it's part of a rootkit, whether it's part of some driver in kernel memory doing security checks, whether it's a DLL, whether it's in userland, whether it's shellcode in userland, wherever that code is, we don't want to have to analyze it by hand. We just want the emulation engine to do it for us and then automatically tell us everything it knows about it. And then, as I mentioned, being able to analyze multiple samples. If I was to give you a thumb drive with, say, 10 Windows memory samples on it, and I gave you Volatility 2, and you want to analyze all of those, it might take a while. And that's a very common scenario, right? People go to the client, they get memory samples, they bring them back to the analyst team, because what you have to do in Volatility 2 is you don't know the profile. So you have to run k2bug scan, or if you want, you can run image info. You then wait a while, anywhere from 1 minute to many minutes, for it to give you the profile name. You then set -- profile on the command line, and then you can run whatever plugins you want. So you would have to do this for every memory sample that you had as part of your investigation. Whereas with Volatility 3, all you have to do is run the plugin. So if you look down here, it's a very simple bash one-liner. So for every memory sample in a directory, we're just running Python 3 against it. We're running windows.pslist. And in this case, I'm just grepping for system, because I know that process will be there. And you can see we have 4 separate system processes being printed. There's one for each sample. So if you want to quickly run something against all of the plugins or against all the samples you have, you can obviously redirect the output to different file names. If you want to do something which is very popular, run your Yara rules against that memory sample. You can take an entire directory, just run the Yara plugin, the Yara scan plugin. It's only going to print out the matches and from what sample they came from. So you can very quickly move through many, many samples without having to do all the k2bug scan and -- profile stuff on your own. It would be very similar for Linux or Mac. Like I said, you would need the symbol tables that represent those kernels, but once you had those, you could just run the loop and it would run the plugins automatically. And then finally, looking forward, like I said, Volatility 3 is under very active development. We're going to talk about that more on the next slide. The goal is by August of this summer, so August 2020, will be the first official 3.0 release. So that is where we will have feature parity with Volatility 2. So everything you can do in Volatility 2, you could do in Volatility 3, but it'll be quicker. And if you're a programmer and you want to do it programmatically, it'll be a lot simpler. And then also these unique capabilities that I presented. And then in August 2021, so 2 summers from now, at that point, Volatility 3 will be the main version of Volatility. Until then, until August 2021, Volatility 2 will be under the same development, so all the updates, all the bug fixes, as new operating system versions come out, we will be supporting it as we've always been. But then, like I said, once August 2021 comes, Volatility 2, I mean, I'm sure the GitHub will still be there and all of that, but the core team will no longer be working on it. We'll be solely focused on Volatility 3. So what this should show you is there's a lot of work left for Volatility 3, and there's a lot of many chances to kind of put your own twist on it. If you want a new plugin, if you want a new feature, you have the chance to do that before the framework is officially released. So if you're interested in that, we have our GitHub page. The same place you can find Volatility on GitHub under the Volatility Foundation. It's just Volatility 3. We have the documentation that's automatically generated for us, and we require all the programmers on our team, and if people do external contributions, everything has to be documented from the start. If you want to talk with us, we have a Slack server, and then we also have a mailing list. So again, the idea here is Volatility 3 is still very much being worked on. The core APIs are done, all of the back-end stuff is done, but as far as the analysis plugin, there's still a lot to write, and there's still a lot of room for improvement and also discussion. So if you don't like how a certain plugin in Volatility 2 works, let us know about it. If you have the ability to do programming, you can write it yourself, submit a patch. If there is some other analysis plugin that you would like to see and you have the programming skills, now is a great time to contribute to that, make that contribution, and be able to kind of help the entire field out. Whether it's just you find it interesting, whether it's something you want to help with your career. We have a lot of students who are really interested in it, doing master's projects, PhD work as well, to really help us push this forward. So we have our core team. We've been around for a while, but we always like more people helping, and the more people that can help, more people that have ideas, it's just going to make the project that much better. So we're very easy to get in touch with. Like I said, check out the code, start to use it, file bug requests, file feature requests, and then definitely do pull requests if you have the ability to code and would like to help us out. And then this will be on the slides online, but I talked about quite a few articles and white papers and stuff. You can always find those at the end of my slides. So otherwise, I'm done the slides. Any questions or anything?